Welcome to digital class. Dear children, today we are going to learn an important and interesting topic from the chapter Polynomials and Factorization. The topic name is Remainder Theorem and Factor Theorem. Children, three friends Raju, Ravi and Reshma have gone to a vegetable market to purchase tomatoes. Three friends Raju, Reshma and Ravi went to a vegetable market to purchase vegetables. They want to purchase tomatoes. The cost of the tomato is rupees 30 kg. So Raju, Ravi and Reshma have gone to the market and they want to purchase the tomatoes, and if Raju purchased 2 kgs of tomatoes, what should be the cost of the tomatoes for 2 kgs? For each kg is 30 rupees, so it is going to be 30 into 2, which is going to be 60 rupees. Suppose Raju purchases p kgs of tomatoes. So the amount spent by Raju is going to be 30 into p. If Ravi purchases q kgs of tomatoes, then he should have spent 30 into q rupees. And if Reshma purchases r kgs, she should have spent 30 into r rupees. So the amount spent by Raju, Ravi and Reshma are 30p, 30q, 30r. So what can you say about the p, q, r here? They are called as variables and 30 is a constant. What could be the total amount spent by three people? Together they have spent rupees 30p plus 30q plus 30r. So where this 30 is a constant and p, q, r are variables. Let us take another scenario here. You want to find the area of the square. The area of the square is given as side into side. The side is given as 5 centimeters. The area is nothing but 5 into 5, which is 25 centimeters square. Now, if you don't know the side, if the side is x units, then the area of the square is going to be x into x, which is nothing but x square. So here x is a variable here, and x square is an algebraic expression. What is an algebraic expression? An expression which consists of constants, variables and algebraic operators like addition, subtraction, multiplication and division is called an algebraic expression. So we'll take example of algebraic expression here. Here you got 5x square here. So what is a 5 called as in this expression? It is called as constant. And what is a x called here? It is called as variable. And what is a 2 called? It is called as exponent or power. So you see that the 5x square is a single term. So we can say this is what is having only one term. So the number of terms is 1. Let us take another example here. 3x by 2y square. So here x and y are two variables. 3 and 2 are constants. The exponent of x is not given, so it is 1. Exponent of y is 2. So you see that this entire thing is a single term, so the number of terms is 1. In 3x plus 5, there are two terms, 3x and 5. So you can have two terms here, and in 5x y cube minus 9x plus y, you have three terms where x and y are the two variables. Today we are going to learn the topic called as polynomials. The learning objectives of today's class is the students will be able to define a polynomial and find the degree and zero of it. Differentiate the constant, linear, quadratic and cubic polynomials. Divide a polynomial with another polynomial. State and apply remainder theorem and factor theorem. So what exactly is a polynomial? So an algebraic expression in which the variables involved have only non-negative integral powers is called a polynomial. Let us take some examples of polynomials. So you see that 3xy is a polynomial. X square plus 2x is a polynomial with having two terms. X cube minus x square plus 4x plus 3 is a polynomial having four terms. Pi r square is a polynomial in variable r. Ax plus b is a polynomial in one variable x. If you got only one term, it is called as monomial. If you got two terms, it is called as binomial. So 3x plus 5, 5xy cube minus 9x are the examples of a binomial, and a trinomial have 3 terms. So you see x square minus 5x plus 2 or 5xy cube minus 9x plus y are the examples of 3-term polynomials. So you can have polynomials of more than 3 terms. You can call it as a polynomial of that particular degree. When can you say a algebraic expression as not a polynomial? If the exponent is not non-negative, then the algebraic expression is not a polynomial. So if you take the expression, algebraic expression as 3 plus x to power 1 by 2, this is not a polynomial because you got the power as 1 by 2. The exponent of x is 1 by 2. 1 by 2 is a fraction, so it is not a non-negative integer. Hence, it is not a polynomial. Take 2x square minus 3 by x plus 5. It is not a polynomial as the exponent of x in 3 by x you can write as 3x to power of minus 1 is minus 1, the negative value here. So you got exponent as minus 1 negative, so hence this is not a polynomial. So even though these two are algebraic expressions, but they are not polynomials. Which of the following algebraic expressions are polynomials and which are not? Give some reasons for that. Root 3x plus 5y, second example is 5, 3xyz, 3 root x plus 5y. So you see this type of questions in the textbook. You can actually try to practice these type of questions. Now we discuss about an important term called as coefficient of a term. Now you see that each term of the polynomial is a product of a constant and variables raised to non-negative integral powers. So the constant is called the coefficient of the term. So we take the coefficient of the term 3x square plus 4x plus 7. So here got 3 terms here. 3x square is one term, 4x is one term, and 7 is one term. You want to find the coefficient of x square. The coefficient of x square is 3. The coefficient of x is 4. And 7 is a constant term. The coefficient of constant term you can write as x to power of 0, which is 7. So the value of x to power of 0, we know it as equal to 1. So the coefficient of constant term is 7. So we can say the constant term is 7. Take another example here. You try to find the coefficients of each of the terms. The first one is 5p minus root 3, and second is pi t square minus 3t plus 5. So you just try to find the coefficient of each of the terms of the following expressions. Now you define the degree of the term in a polynomial. Each term of the polynomial has finite number of variables raised to non-negative integral powers. So the degree of the term is sum of the exponents of its variables. Take an example of 3x square y square. So this is a polynomial in 2 variables x and y here. Now see that the exponent x has power as 2, exponent y has power as 2. So you can say that the degree is exponent x square power is 2 here, so y square power is 2 here, so it is 2 plus 2, which is equal to 4. So children, so the degree of this polynomial is 4. The highest degree among the degrees of the different terms of the polynomial is called degree of that polynomial. So let us find the degree of the polynomial 3x square plus 7x plus 5. So you got 3 terms here. One is 3x square, second is 7x, and third is 5. The degree of x square here, you want to find out degree is 2 because the power is 2 here. The degree of x here in 7x, no power here, the exponent is 1. Degree of the constant term is 0. Out of these 2, 1, 0, which is the maximum one? So 2 is the maximum one, so therefore you can say the degree of the polynomial is going to be 2. So you just try to practice these questions here. Find the degree of 7x cube plus 5x square plus 2x minus 6 and pi t square minus 3t plus 5. We will discuss about the type of the polynomial here, the degree, name of the polynomial and examples. If you take the constant polynomial, so once you say it is a constant polynomial, the degree is going to be 0. So you see that the constant polynomials have only constants. So say example as 5, minus 3, minus 5 by 2, 3 by 4. These are all examples of the constant polynomial. Because it is not having any variable, the degree is going to be 0. The linear polynomial. So the word linear, it means that the degree is 1. So once you got a linear polynomial, the degree of the polynomial is going to be 1. Take 3x plus 5. So the degree of x is 1. Minus 10 plus y, the degree of y is 1. So the polynomial minus 10 plus y has degree 1. The polynomial 3x plus y has degree 1. Quadratic polynomial. So the word quadratic means it is having 2. So the degree is going to be 2. So example, you take it as x square minus 5x plus 1. So degree of x square term is 2 here, degree of x term is 1 and degree of constant term is 0. So the maximum of this is 2. So degree of this quadratic polynomial is 2. A cubic polynomial has degree 3 here. You can take example as x cube minus x square plus 2x minus 3. So you can create your own examples. Now if you take 0 polynomial, now what could be the degree of 0 polynomial? If you take the constant polynomial, in place of numbers, if you put a number as 0 here, it is going to be a constant polynomial. So you can say that the degree of the constant polynomial is not defined. So you can take example as 0. So why you say it is not defined? So you can write as see 0, you can write as 0 into x to power of 1 or 0 into x to power of 2 or 0 into x to power of 3. So you will not be able to assign a proper variable to the attached to this. So you can say the degree of the 0 polynomial is not defined. Now we define nth degree polynomial. A polynomial of degree n in variable x is an expression of the form a0 x to power of n plus an minus 1 x to power of n minus 1 plus goes on plus a2 x square plus a1 x plus a0. So this a0, a1, a2, a3 goes on, they are all constants and the term an is not equal to 0. So if you got an is equal to 0, then the first term is going to be 0, you will have this term as the first term. So you should have an as not equal to 0 because you said that degree is n here. Generally polynomials are represented by p of x, q of x, r of x, so on. We take a p of x as 3x square minus 2x plus 1. So you can say this is a quadratic polynomial in variable x. Take q of y is equal to y cube plus 4y square plus 3y by 2 minus 1. So we can say this is a cubic polynomial in variable y. We take r of z is equal to z to power of 4 minus 1. You can say this is a polynomial of degree 4 in variable z. So we can have polynomials of more than one variable. You can say x plus y is a polynomial in two variables x and y. Likewise x square plus 2x plus y square or x square minus y square. They are all examples of polynomials in two variables x and y. You take x square plus y square plus z square. So you see that there are three variables here x, y, z. X cube plus y cube plus 3xy plus z cube. Here also you got three variables. So these are all examples of polynomials in three variables. So we can have as many variables as possible here. We can define the polynomial for that number of variables. Now we discuss about the value of the polynomial. If you take an example of p of x is equal to x square plus 5x plus 4. So let us find the value of p of x at x is equal to 1. So what is the meaning of it? You are going to replace x with 1. For that we have to replace x by 1 in p of x. So in place of x you are going to put 1. So p of 1, if you find out in place of x it is 1. So 1 square plus 5 into 1 plus 4. So 1 square plus 5 into 1 plus 4. So 1 square is 1, 5 into 1 is 5 and 4. So it is 1 plus 5 plus 4. It is going to be of p of x is equal to x square plus 5x plus 4 at x is equal to 1. So what you can do is you can just find the value of p of minus 4, p of 0 and p of minus 1. So replace x with minus 4 here, replace x with 0 and replace x with minus 1 and observe the values there. So let us discuss about a concept called as 0 of the polynomial. A 0 of the polynomial p of x is the value of x for which p of x is equal to 0. So you observed in the previous example s of 2 and s of 0 was 0. So you got a x value as 2 and x value as 0 for which p of x is equal to 0. So a 0 of the polynomial p of x is the value of x for which p of x is equal to 0. Take p of x is equal to x plus 3. 0 of x plus 3 is obtained by equating it to 0. So equate this p of x with 0. So p of x is equal to 0 means you can say x plus 3 is equal to 0. So bring this 3 onto the right hand side, you get x is equal to minus 3. So x is equal to minus 3 is 0 of the p of x. We can have a quadratic polynomial in one variable which has maximum of 2 zeros. We can have a cubic polynomial in one variable having at most 3 zeros. In general, a polynomial of nth degree has at the most n zeros. Problems yourself, verify whether x is equal to minus 1 and x is equal to minus 2 are zeros of the polynomial p of x is equal to x minus 1 into x plus 2 or not. So you put x is equal to minus 1 and x is equal to minus 2 here. Division of polynomial. So let us take an example of numbers and try to divide 25 and 3. So you want to divide 25 by 3 here. So how you do it here, you write, when you divide here you get the quotient and you get the remainder. So you can say that 25 is a dividend, 3 is a divisor, 8 is a quotient and 1 is a remainder. So the relation between them is 25 is equal to 3 into 8 plus 1. So we can say dividend is equal to divisor into quotient plus remainder. So dividend is equal to divisor into quotient plus remainder. Divide x cube plus 3x square plus 3x plus y by x plus 2. So here it is a binomial or a linear polynomial. So when you divide here, you get x plus 2 as a divisor, x cube plus 3x square plus 3x plus y as a dividend. So what is the first step here? You are going to divide the first term here with the first term here. So x cube by x is going to be x square. So that is going to be the first term of the quotient. So you get x square as the first term. Now you take this x square, multiply with x plus 2, you get x cube plus 2x square. So that is going to be the term which you get below the first two terms. Now you can go for subtraction. You see that the x cube and x cube cancel off and you can write 3x square minus 2x square as x square plus 3x plus 5. X square plus 3x plus 5. Now you take the step 2 here. You take the first term as x square and the first term is x. So divide x square by x, you get x. Now this is going to be the second term of the quotient. So you get plus x here. You are going to multiply the x plus 2 with x here. You get x square plus 2x. So bring it down to the x square plus 3x plus 5. So you get x square plus 2x. Now you see that you can go for subtraction. X square and x square cancel off. 3x minus 2x is x and the remainder is 5. So again, because you got same degree here, again you can go for a further division. So you can divide the first term x with x here. So x by x is 1. So the third term of the quotient is 1 here. So you're going to multiply x plus 2 with 1. So you get x plus 2. You're going to put it down to the x plus 5. So you can go for subtraction. You can see that the remainder is 3 here. So what you are observing is the quotient is x square plus x plus 1 and the remainder is 3. So what is that you observe here is the degree of the remainder is 0 and degree of x plus 2 is 1. We observe that degree of the remainder is 0. We observe that the degree of remainder is less than degree of x plus 2. So we can have dividend is equal to divisor into quotient plus remainder. So if you take p of x as the dividend, g of x as the divisor, q of x as the quotient, r of x as the remainder, you can say P of x is equal to Q of x into G of x plus R of x, where either R of x is equal to 0 or degree of R of x is less than degree of G of x. So with this input we discuss about important theorem called as remainder theorem. So let P of x be any polynomial of degree greater than or equal to 1 and let a be any real number. If P of x is divided by a linear polynomial x minus a, then the remainder is P of a. If P of x is any polynomial of degree greater than or equal to 1 and let a be any real number, if P of x is divided by a linear polynomial x minus a, then the remainder is P of a. So if you take the g of x as x minus a, then you can say the P of x is equal to x minus a into Q of x plus R of x. So you can say x minus a is a polynomial of degree 1. So you see this is a linear polynomial. So x minus a is a polynomial of degree 1. So you can say that degree of x minus a is 1. So degree of R of x should be equal to 0. So you can say R of x is a constant. You can take R of x as k. So take for every real number x, R of x is equal to k. So therefore P of x is equal to x minus a into Q of x. In place of R of x you are going to put k, because you have taken R of x is equal to k. So if you put x is equal to a here, so you can say P of a is equal to x is a here, so a minus a into Q of a plus k. So a minus a is going to be 0. So you can write P of a is equal to 0 into Q of a plus k. So you can say P of a is equal to k. So earlier you have taken R of x is equal to k, now you got P of a is equal to k. So therefore the remainder R of x is equal to P of a. So this is what is the proof of remainder theorem. So very important observation you can make here: if a polynomial g of x is said to have divided a polynomial p of x exactly if the remainder is 0. So that is, if R of x is equal to 0, then you can say P of x is equal to g of x into Q of x plus R of x, because you are saying R of x is equal to 0 here. So you can write P of x is equal to g of x into Q of x for some polynomial Q of x. So you can say g of x and Q of x as factors of P of x. So let us take an example here. Find the remainder when x cube plus 1 is divided by x plus 1 here. So let P of x is equal to x cube plus 1, and you want to divide x cube plus 1 with x plus 1 using the remainder theorem. So the 0 of the linear polynomial x plus 1, if you want to take, how to find linear 0? You take x plus 1 is equal to 0. It means that the value of x is minus 1. Put x is equal to minus 1 here. So the 0 of the linear polynomial x plus 1 is minus 1. So if P of x is divided by linear polynomial x minus a, then the remainder is P of a, where a is the 0 of x minus a. That is what is the remainder theorem. So you put x is equal to minus 1, you get P of minus 1 is equal to minus 1 whole cube plus 1. So minus 1 whole cube plus 1 is minus 1 plus 1, which is going to be 0. So therefore by remainder theorem, when you divide x cube plus 1 by x plus 1, we get the remainder as 0. So you got the remainder as 0. If you got remainder as 0, we can say that x plus 1 is a factor of x cube plus 1. We discuss about an important theorem called as factor theorem. If P of x is a polynomial of degree n greater than or equal to 1 and a is any real number, x minus a is a factor of P of x if P of a is equal to 0. And if x minus a is a factor of polynomial P of x, then P of a is equal to 0. This is what is a converse statement. So how is it you prove this? We just have remainder theorem. P of x is equal to x minus a into Q of x plus P of a. Because you are dividing with x minus a, you got the quotient Q of x. So you put x is equal to a here. What is going to happen is, so you put P of a is equal to 0, then P of x is equal to x minus a into Q of x plus 0, because you have put P of a is equal to 0. So you can say P of x is equal to x minus a into Q of x. So you can say that because you got a factor x minus a, so x minus a is a factor of P of x. Conversely, if x minus a is a factor of P of x, then P of x is equal to x minus a into Q of x for some polynomial Q of x. So in place of x you put a here. P of a is equal to a minus a into Q of a is equal to 0. So a minus a is 0 here, 0 into q of a is 0, so the p of a is 0. So what is the proof of factor theorem? So important observation, if p of x is a polynomial, then the following statements are equivalent. So a is a 0 of p of x, x minus a is a factor of p of x, and p of a is equal to 0. So p of a is a 0 of p of x, x minus a is a factor of p of x, and p of a is equal to 0. Examine whether x plus 2 is a factor of x cube plus 2x square plus 3x plus 6. So you got p of x is equal to x cube plus 2x square plus 3x plus 6. You take x plus 2 as g of x, so g of x is equal to x plus 2. So the 0 of g of x is minus 2. Because you want to get 0 here, you replace x with minus 2 here, so minus 2, you get 0 here, so g of x, 0 of g of x is minus 2. So put x is equal to minus 2 here, so p of minus 2 is equal to minus 2 whole cube plus 2 into minus 2 whole square plus 3 into minus 2 plus 6. So it is going to be minus 8 plus 8 minus 6 plus 6. So the answer is going to be 0. So you can say by factor theorem, x plus 2 is a factor of x cube plus 2x square plus 3x plus 6. Factorize x cube minus 2x square minus x plus 2. So you take this as p of x, x cube minus 2x square minus x plus 2. So degree of p of x is 3 because you got x cube here. So p of x has at the most 3 factors. So first of all, you try to find one of the solutions. So you are going to use a trial method. You take one value of x. So if you put x is equal to 1, what happens here is 1 cube minus 2 into 1 square minus 1 plus 2. So you get 0 here. If you are not getting 0, try to put some other value, say x is equal to 2, x is equal to 3. It is your choice. You see that whether you are getting 0 or not. So this method is what is called as trial method. So you can say 1 is a 0 of p of x. So you can say x minus 1 is a factor of p of x. So to get the remaining factors, you divide x cube minus 2x square minus x plus 2 with x minus 1. X cube minus 2x square minus x plus 2 as a dividend, x minus 1 as a divisor. So the first step is going to be divide x cube by x. You get x square, that is what is the first term of the divisor, first term of the quotient. X minus 1 into x square is going to be x cube minus x square. You put it down here. Now subtract. So minus 2x square plus x square is minus x square. Bring the remaining two terms down here. The first term is minus x square. So divide minus x square by x. So you get minus x. Now the next term is minus x here. Multiply x minus 1 with minus x. You get minus x square plus x. That is what is the next term. Now you can cancel x minus x square plus x square, and you get minus 2x plus 2. So step 3 is going to be divide minus 2x with x. You get minus 2. Now that is what is the third term of the quotient. Now multiply x minus with minus 2 here. So you get minus 2x square plus 2. So when you just subtract here, you see that both the terms have got remainder is 0. So you can say x square minus x minus 2 is another factor. So you can say x cube minus x 2x square minus x plus 2 is x minus 1 into x square minus x minus 2. So x minus 1 is a factor of p of x, and the quotient is x square minus x minus 2. So let us factorize this x square minus x minus 2. So we can write x square as 1 into x square minus x minus 2. So multiply the coefficient of x square and constant term. 1 into minus 2 is minus 2. So you can say 1 minus 2 is minus 1. What is the next middle term here? So you can write as 1 into x square plus x minus 2x minus 2. You see that first two terms x is common. You get x plus 1. In these two terms you got minus 2 common, x plus 1. So in these two terms you got x plus 1 common. So x plus 1 into x minus 2. So you can say the factors. The first factor is x minus 1, second factor is x plus 1, third factor is x minus 2. So factors are x minus 1, x minus 2 and x plus 1. So you try to solve the problems here yourself. Factorize 12x square plus 11x plus 2 and x cube plus 13x square plus 32x plus 20. And another problem, show that x plus 4, x minus 3 and x minus 7 are factors of x cube minus 6x square minus 19x plus. For better understanding of the concepts and for worksheets, please visit our official website SCRT Telangana. Thank you, children.